Can anyone give us a summary of that uh, last class we did on Friday? Though it was a tutorial class, but can I get a recap of what we've done? Or even though it's in the first class, so what we've done so that let me understand your understanding regarding the background that we are still discussing. Mr. Jackson. Jackson, are you there?
Yes, I'm here, sir. I'm trying to get my notes ready.
Okay.
I didn't review the notes here, but I know you spoke about the individual decision making process in the microeconomic perspective. We also spoke about choices and preferences and how to make rational decision using the tools of microeconomic theory. This is the few that I can remember.
All right. Thank you very much. Exactly what we discussed. Um, Ame, are you there? Ame, Mama, are you there?
Yeah, yeah, I'm here. Please, so since that day, I have not gone through this thing at all. I have to be sincere with you. I have not gone through it.
All right.
But I
But
know that day that I was very, I mean, involved in I was participating in the discussion. But today, I cannot really begin to recall what we did that day. Thank you.
all right. Uh, Faisal, Faisal, are you there? Faiz, are you there? Yeah. Can you can you give us a recap of what we've done so far? We are waiting for you. Let's have a recap of what we've done from you or what you understand so far in the course. All right. So while we are waiting for Faisal to give us his own perspective, let me just quickly summarize what we've done. Or let me quickly make this statement. One thing about this class, like I said in the other class, that we need to write and read consistently. We shared some of the material with you. The lecture note has been shared with you. The video, I think, has also been shared, and also some textbooks. Uh, the recommended textbooks has been shared, or you can also get them online. They are open source textbooks. So these books, we need to read them consistently for you to follow the concept of this subject. Like I said, it is mathematical. It is not something you can just wake up and read and understand it quickly. You need to consistently solve this problem to get used to the concept. Please, all right. So let's proceed with the class. So so far, we've discussed the concepts, like Mr. Jackson rightly said, we've discussed the tools, some of the basic tools we need in, to make decisions. So, among those include preference, choices. We said preference, choices must be made before preferences. Okay, but one of the fundamental tool or one of the first step we need to take in decision making is individual preference. So preference are we can make our preferences in the choice of alternatives. Okay. So and we also look at when making preferences, what are the utility that are associated with these alternatives that we want to make. So that is where utility came into it. So utility actually means the satisfaction one derive from the particular alternative. Okay, so such alternative in making preferences, so must look at the utility one is benefiting, or preferences that worth for a decision maker to make decision with. No, not all preferences. Some are rational, some are what irrational. So for the sake of this study, we are looking at a rational preference. Okay. So we said that a rational preference are those preferences that satisfy two important axioms, which is what? Who can tell us those axioms? Anybody with those axioms?
Transitivity and completeness.
Right, that's good. So transitivity and completeness axioms, they are very important. So once they satisfy these two, say completeness is where we prefer a certain alternative to another alternative. Okay, so that is completeness. It is preferred. But if it's at least as good as, then is still complete. So when we have that comparison, our rational preference could be straight, could be weak. Okay, so when it is straight, we said it is preferred. Then if it is weak, we say it's at least as good as another alternative. Okay, so completeness, we are saying that a certain preference X is preferred to Y, all right, or is at least as good as Y. Then, if we are having three alternatives, then transitivity can creep in. Okay, so we can discuss the idea of transitivity when three alternatives are involved. So all these are some little concepts we discuss, and we also discuss the concept of choice, how we make choices from a certain budget. And we discuss the budget sets, how we construct our budget in the last class. To said to construct a budget, we look at the subset of a preference. Like I gave certain instances where we have our preferences to have three alternatives, and we expect to have at least eight subsets from that, from the law of sets. So we did that distribution in the last class, and we arrive at those eight subsets. So a combination of this subset is what made up a budget. Okay, so that's why we have our C. That's why we have our budget sets, this and a C set of choices. So when you say C of B, okay, it contains sets of alternative. Remember B. Remember B is the Remember B is the set, is a subset of our preference. Okay, so those sets that contain those elements that contain in B. So a set of them, they are the choices a decision maker is trying to consider. Okay, so the choices, the choice structure is made up of the budget set and the choice rule. So these six dots represent this choice rule. Remember that this dot is what? Is a set that contains what? B, which is some element of our X. So like we rightly have it here that B is a subset of what? X. So we look at these examples. We look at this last class and we consider all these examples in the last class. So if you're having X to be a set of this and this is a budget set that contain all of this. So you remember that, remember how we form all of this subset in the last class. So, right. So and we consider some examples of choices using the choice rule. Okay, so we have that if we are having your C of this is a set, a choice, so a consumer's choice, and X is what? X, this set X is the preference, okay, of this choice. All right, so these are X, Y is a preference of what? Of this choice X, Y, Z. So a consumer or a decision maker can be given a decision maker can be given a set that looks like X, Y, and Z. Okay, so and the decision maker is making a choice of what X and Y. So that is his preferences from this set. Okay, so these are some things we looked at, and we also said that there might be some restrictions. Okay, there might be some restrictions we want to include in this set. Okay, so some reasonable restrictions that can be made or that can be imposed on this uh, choice structure. Okay, could be we want a consistency. We want a certain behavior to be consistent. So that is why we are adding these restrictions. Okay. So one of those restrictions is what, or one of those assumptions we are imposing on this structure, choice structure, is a weak axiom of revealed preference. So, but before we go into weak axiom of revealed preference, so we would like to know what ray, what weak axiom actually means. Okay. I hope the class can hear me loud and clear. Am I audible
Yes, sir.
enough? All right.
Very audible.
All right. So this can. All right. So uh, before we discuss the concept of weak axiom, weak axiom actually means. Axiom itself is just like what? It's just like a postulate, that is a theory, not a theory per se. So it's just like a a rule, okay? A rule, something that has been verified. So just like an axiom, just like we have uh, some usual axiom we are familiar with. I think we've stated some two axioms here: the axiom of weak, the axiom of completeness, and the. So these are just some stated rules, okay? Some stated formulas that we need to follow. So axiom. Now, when we say it is weak, okay, what we are trying to say is that ability for a consumer to afford a particular preferences. So that's what we know to be what a weak axiom of a review preference. When we are faced with a set of alternative, so which of these alternative is affordable? Okay, so that is what we mean by that is what this postulate is saying. Like we rightly have it in the slide there. So I think I gave the definition of a weak axiom here. Okay, so it said okay, the weak axiom of a review preferences. So it is if we have a set structure that satisfies the weak axiom of review preferences, then this is the condition that must be held. So if we have a set B, which is a subset of our budget set, this does anyone understand what this statement means? B is a subset. B is an element of a budget set. Do you understand that clearly? Or I should explain with good examples. Just want to get some response on that.
Hello, sir. Good evening.
Yeah, good evening.
Like you said, I think it would be good if you use some life examples so that you be able to understand it better. Because you are explaining set theory, isn't it?
I can, please come again.
I say you are explaining set theory, isn't it?
Yes, I've
Because
explained.
the set theory we used to know in our early university days. It's not the same that you're teaching here, so the thing is looking quite abstract somehow, or maybe too cumbersome.
Please come again. Let me get it clearly.
I said the set theory we learned in early university
Yeah.
is not the same that we are seeing now. This one looking quite cumbersome. I don't know for others, but to me, that's. That's the way it
Okay.
is written. So I don't know if you can break it down more, maybe by adding reality, add reality to the alphabet, to the algebra, so that somebody can get it easier as you are explaining. Thank you,
Oh,
sir.
all right. Thank you. So I will let me quickly open to my other machine and show you some what this be in this budget set actually mean. Then I will use this opportunity to explain the concept of sets to everyone. All right. So let me share my screen and explain what set means. Yeah, can you see my screen now?
Yes, sir.
Okay, let me quickly discuss sets. Okay, so set is denoted by a capital X. Okay, so this is a set. Now, it is always defined by this. All right, so let's say I have an item. Let me say I have some item in this set, which could be X, Y, and Z. Okay, so let me say this is a set. This is a set that contains three elements. So this item inside this set are called elements of the set. Okay, so now the set, like I said in the last class, so contains a lot of so it contains subsets, so which is always denoted by to calculate the subsets in the set. We use this formula 2 to the power of what? To the power of the numbers of elements in that set. So we say 2 to the power of n, for instance. So we use 2 to the power of n to denote the elements in that set. Okay.
But we have three elements of set here. Why is it 2 to the power of n?
Yes, I'm just generalizing it. All right. So we are generalizing it in this case to be n. So for this case now, what's our n? Our n is what?
3 raised to
Our
power n. 3
so
raised to
our
power
n
3,
is
sorry.
3. So our n is 3 in this case. So this becomes what? This becomes 2 to the power of what? 3, right? So this becomes 2 to the power of 3, and that becomes what? 2 to the power of 3 is what? Is
6.
8. Is 8. It's like 2
Okay,
times
okay, that's
2.
2. Okay, 2 times 2 times. Okay, 2 in 3 places.
Yes.
Okay.
So that would be the number of elements in that set. So now, let me list out all these elements in this set. So like in the last class, we have it, right? So we said the first element we can have in the set is the set that contains, let's say, only one item, right? The set that contains only one item. We can also have the set that contains only y. So that will be set number 2. All right. So please just get this basis very clearly. So set number 2 will be the set that contains only y. Right. So a set number 3 will be the set that contains only z. Okay, so set of single items. So that is set number 3. Okay, who can tell me the next set we are going to have? The fourth set will be what? The set that contains 2 items, right? I hope I'm loud and clear. So the
We
set
can
that,
hear you loud and clear.
all right,
I
the
was
set that,
offline and back.
all right, thank you. So the set number 5.
Hello, sir. Sorry to cut you back a little bit. Why are we having that? The text, yes, the curly bracket is covering the text. Why are we having that S and those two those two bent lines or something? I don't know how to call.
Okay, don't worry
As we
about
are
that, okay?
denoting. Oh, okay.
Don't worry about the left side of my panel, all right? So focus on this side, okay? Just focus on this side. Leave the side for me. Is that clear? So, so the set that contains um, x and z would be a good choice for us, as the set, another set that we can derive from here is the set that contains y and z, I guess.
I and Z.
Yeah. So that set we can consider. Anybody raising up his hand? Farouk, go on. Yeah, Farouk, you can speak up. So the seventh set that we can also derive here. You can tell us.
It's XYZ.
Thank you. So that is another set. Why the last set? You can tell us the last
It's
set.
empty set.
The empty set. God
Empty set.
bless you. Yeah. So the set that contains nothing. So the, so the empty sets. Now these are the possible sets that we can have in this subset. Okay, these are all the subsets we can have.
Oh, this soap is giving me a challenge.
Then, then we can have a set, a subset. So in my definition here, I call something a budget set. So I said a budget set. So in that definition, I have all B's here to be B. Okay. Instead of X, I denote them with coily B. So let me take some definition here. Okay. So let me call this X. Okay. Then let me call this one B. Let me call this, instead of calling it X, let me call it B. Okay. So let me call this B. All right. Instead of calling it X, let me call it B. Okay. Let's also call this guy B2. All right. Right, let's call the next set B2. The next set, let's call it B3.
Three.
Okay, so they are just my budget sets. Okay, so this is B3. So this is B4. I hope they are reflecting on my screen. Yeah, so this is B5. There's an error here. This is B4. This is B5. This is B6. All right. This is my B7. And this is my budget set 8. All right. So now we have a budget set 8. So what I mean by saying that they are subsets, or B is an element of X. Okay. So I can call this my B. So these are my 8 set. Okay. Now I can have a set, let's say B1. So if I'm saying the set B1 is a subset, if I'm saying the set B1 is a subset, if I'm saying the set B1 is a subset of X, what do I mean by this? So, so what I meant by set B1 is a subset of B is that this element B1, which contains what? X1, can be found, okay, can be found in what? In X.
In X, yes.
So that is what I'm saying. Can be found in X. So that is what I'm saying in particular. That if I say B1 is a subset of X, okay, X is contained in what? In big X. All right. So if I'm saying that this set, let me say B2, if I'm saying this set B2 is contained in X, so who can tell me what this implies? So if I'm saying the set B2 is contained in X, who can tell us what this implies? Anybody? Anybody? So
What's the
what's
question, please? My the sound is
oh,
breaking on
okay?
my network.
If I'm saying this set B2, this B2 is a subset of X, what does that mean? And what
It means
it
it
means that
means
Y,
set B can be found in X.
yes. So what's my B2 of? My B2 is what? Y from this place. My B2 is what? Is Y. So it means that Y can be found. Y is contained in X. Okay. So now, if I define a family set, okay, remember I have one family set that I always use. Can Okay, let me share my other screen. show you something. So now back to this screen. If I'm saying that B contains in this other coily B with X and Y elements of what? B. So what I meant is
Your
that
sc- your screen has your screen has gone down. I don't know if it is from my end.
okay. I guess it's from your end. Can you see my screen clearly?
Yeah, we can see your screen. I guess it's from his end.
Okay, all right. So now if I'm saying that B is an element of this B, it means that this B can be B1, B2, like I have it here B, you can see another B here, B prime, okay? So B prime is representing what? B2. B is representing B1 from the way I defined it earlier. So if I'm saying B is contained in this coily B, this coily B is the family set, okay? Is the bigger set, is the budget set. But I can define a little set out of it, that is a subset from this B. That is what we meant, okay? So that contain X and Y. So it's a subset. You saw when we broke that set down. So I hope I have answered your question, Edusi. Edusi, I hope your question has been answered. She's not there anymore. So that is what we meant by this. So by definition of our weak axiom, we are saying that if we can have two subsets of our family set B, remember in the last class we defined B to be a family set. B is the subset. All right. So if we can have two subsets from this family set such that this set contains X and it also contains Y. Okay, this budget set B contains X and contains Y. Then with X and Y also in the other sets we define. Right. So if Y Y is in CB, what does this mean? Y is contained in CB. That means Y, remember that CB is the choice room. Okay, CB is the choice room, just like I have it here. CB prime is the choice room. So if Y is contained in this CB, that means Y is our what? Preference. All right, Y is the choosing value, just like we have it here. I said C2 that contains X and Y. If I'm choosing X, so another way to rewrite this is in this form. Okay, so instead of saying is equal to X, the set of X, we can rewrite it in this form. Y is contained in CB. Is that clear? So, so from this choice, we've chosen Y. That means Y has been revealed. That is what another way of pronouncing it. So we say Y is revealed in this choice from this choice room. Y is revealed. So also X is revealed from this choice room. All right. Any question regarding this definition? So for weak axiom of a revealed preference to hold, if we can choose, if we have a set that contains B from the family set and X has been revealed, is saying that, and in the other set Y is revealed, so we must always review X. X will be the product of that set. That is what we call weak axiom. That means what this consumer or this decision maker can afford is X. All right, that is what this definition is saying. Any question regarding this definition, I should explain.
Please come again. I don't understand.
All right. So, do you get this example clearly?
There's this one at the top here.
Yes.
I know that you said that the curly B is the family set. While C2
Is it?
is made up of different members of the set, right?
No, C2 is the rule, the choice rule.
The choice room.
Yes.
Okay. Okay, that's where somebody can make choices from.
Yes. So
Okay. Okay.
C2 is actually a choice someone has made.
Okay.
C1 is a choice someone has made.
Okay.
Yeah. If you look on the definition, it is just C. All right. If you go
Yeah.
back, just C is C. So when you say C1, it means one decision was one person made that decision. All right. So C2
Okay.
is another decision someone made. All right. So now, what does this say? C2 that contain X and Y. X has been revealed. Okay. So in this other one, C2, X and Y was the preference of this person. Let's say
Okay.
it's
Okay.
just
Okay.
let me break it down a little bit. It's just like a questionnaire. A questionnaire contains, let's say, three items. What is your name? What is your favorite food? And what is your home address? All right. So these are the three items, and you give someone the questionnaire to fill. So the person decided to fill two items out of it, which is what is your name and what is your favorite food, and he left the other one. So those are the preference the person decided to fill. Understand? So
Okay.
that is how we arrive at it. So these are the preferences. So these are the
Okay.
sets. This set contain the choices the person wants to make.
Okay.
So X can be a let me say X can be a phone. Let me say going to graduate school, going to business school, and this can be another item in that list. So it's a choices. So out of these choices, is making only two choices out of it. So
All right.
that, yeah. So another way of writing this, that X is a preference from this choice. Another way of writing it is through this method. We say Y belongs to X, C of B, or X belong to C of B. All right. So this is another way of rewriting all of this. So the preference here is X. In this place, the preference here is Y. So Wikasm is saying that a situation where X has been revealed, okay, X has been revealed here. There is no set that Y is revealed. X must also be revealed. That is what this definition is saying. So you say if we have a stress structure B, poly B and C, then if B is a set, if B is a set in that family set, all right, that if we revealed X, if the choice is that X was revealed and from a particular set, and in the other side, Y is revealed, so X must always be revealed. That is what this definition is saying. I hope it's clear now.
So I got up to the other point, but when you came here, I didn't understand what you were saying again. But anyway, continue. I'm sure I'll catch up. I'll catch up. Don't worry.
All right,
Continue.
all right, all right.
Thank you.
So now we say, in other words, the weak assumption says that if X is ever chosen whenever Y is available. So if you want to say this in words, okay, if you don't want to use these mathematical expressions, it says that the weak assumption says that if X is reviewed, where y is available, then there is no set that contains both alternatives for which y is chosen, x is not chosen. Alright? So x must always be chosen, whichever set that comes from this family set. As long as y x has been the first item has been revealed, all item that must all item that will be revealed, x must also be revealed. That is what the weak cousin is saying. So now, uh, okay, okay, this is the same example I was citing the other time. You can see that c of x has been revealed here. The preference of this choice is x. All right. So the weak assumption says that what we cannot have a set that contains three items where y will be revealed. All right. So if we have that set, it does not support the weak assumption. It means that it's not affordable for that decision maker. That is how we interpret something like this. If y is reviewed, it's not affordable, it's not the best option or the best alternative, then we can't have a choice of this type. Alright, so here we have another example. So here we have another example. So consider a choice structure of this type, right? So we have a choice structure like this, and this is a budget set. Remember the way I was constructing my subset, all right? So this has been constructed for us in this question. You may come across a question where the budget set has not been constructed. Okay, so you need to construct your budget set yourself. You can be given the preference set, which is X. Just like in the last example I solved, I choose a preference set that contains X and Y, and I list all the subset and form my budget set. Okay, so this one has been constructed. We have X, Y, and then we have X, Y, Z. So this family set contains two subsets, all right, two items. So now we in the question, X has been reviewed. You can see that the preference of this choice is X. X has been reviewed. Also, if we so the question says show that if this set we show whether this set satisfy the weak assumption, right? Then if it satisfy the weak assumption, then this following set, I mean this choice that contains three set is equals to Z must hold. That means this set that contains three set equals to X must hold. Or this choice set whose preference is Z must hold. Or this set whose preference contains two items X and Z must hold. So here is just a simple way of showing it. Alright, so we said if y is contained in this set, so that's your first assumption. If y is contained in this set, then we must state the weak assumption, which implies that y is contained in this set. That means we have revealed, if we have revealed y, remember x has been revealed in the question. So a decision maker revealed y, okay? Then the weak assumption says, according to the weak assumption, if y has been reviewed, definitely, whichever case, y must always be reviewed. Is that not true? To go back to the definition, it says if x, it says if x has been reviewed, definitely x must always be reviewed. So we can also say if y has been reviewed, definitely y is always reviewed. Okay? Or if z has been reviewed, z will always be reviewed. That is what the Wickham is saying. Whichever subset you pick, if you have B1, B2 up to Bn from that set, as long as X, which is the first item, has been reviewed, X must always be reviewed in the entire process. So also in this question, we can see that X has been reviewed. All right, we are given a set and X has been reviewed. Please, can you just give me 3 minutes? 3 minutes, let me fix something. All right, I'm back. Are you there? All right. So, like I was explaining, to if we have a set where this item, this choice has been revealed, which is X and Y. X has been revealed. Now we take a bigger subset from the budget set. Okay, Y Y was revealed from this set. Then the weak assumption says that then the weak assumption says that Y will definitely be revealed from this process or from this statement that we have made here. Y will definitely be revealed. Then this is a contradiction to the definition of X in this question or in this part. This would be what? A contradiction because in the question, X has been revealed already. Then if we are revealing Y, definitely it does not satisfy this process. So Y cannot be a choice or a preference of this set. Do you understand this? Do you understand this example? Any response?
Hello, sir.
All right.
Sorry, sir. I think that's why I said I should use maybe examples to explain. Like this particular, you can use examples to explain for us so that we can get it better. Please.
Okay, the X and Y is confusing you.
Yes, because the way you are putting it, that if X is not in this choice, then it's sort of it's a lot logical. So let's add something to it that can make it easy to understand. Then we can pick it up from there.
Okay, so we should use more practical example. Okay, let me use a very let me use a good just a real life situation to explain what this maybe you've not gotten the definition of weakism clearly. All right, so let me use a real life example. All right, it's like it's like someone who is going to a graduate school, all right, but whose choice is to go to school now. Or his first choice is to go to business school. His second choice is to go to uh, law school, and the third choice. Let's if you look at that, let me be consistent with this example. All right. So the first choice is to go to law school. The second choice is to go to graduate school and study economics, and the third choice is what is to go to business school. So these are the three choices of that person. All right. So now in this example, this reveal preference of Wickham is saying that if the first choice of the person is to go to graduate school and study economics, there won't be any choice of what of studying law. All right. So every choices we are going to make or in all combinations. You remember we are having 8 combination in that set. We can combine this set in 8 ways. Do you remember? I want a response to that. There are 8 ways we can combine this set. Go to graduate school, go to law school, and study economics, go to business school. There are 8 ways of combining them, which I have already splitted down the other time. So if the first choice is to go to law school, all right, there won't be any choice to go to graduate school and study economics or go to business school. Every combinations we are going to be having must contain to go to law school. Since this is his first choice, that okay, my first choice is to go to law school. All right. So any choice I'm going to be having must always be go to law school. Go to law school will always be the preference, since that is what he has chosen or that is what he has revealed. I don't know if that is clear. Is that clear? So if we have a situation like that to go to graduate school, if we have a situation like that, so we can call X going to graduate school, going to law school, all right. X can be going to law school, come back here. X can be going to law school, Y can be going to business school. Okay, so if X has been revealed, go to law school has been revealed, definitely any set that contains Y, go to graduate school or whatsoever, meaning that going to law school will always be the choice. That is what he can afford. I don't know if that's clear. So before one make a preference, it depends on what he can afford. Okay, or I can afford an apple for uh, an orange. All right. So apple is his preference, but that is what he can afford. So whenever he come in contact with oranges, he preferred apple. So that is just what we are saying. So in this context, we are using X to represent it instead of listing a whole lot of alternatives. So let X could be anything, Y could be any alternative. Okay, so as long as the decision maker choices or his preference is to reveal X as his best choice, definitely any set or any subset that we can find must always contain X, which is this choice. So can we move on from here? Okay. Okay, like the example we're considering. So the solution says that if Y, because in the question, X has been what? X has been revealed. All right. So we now assume that if assuming that Y is revealed, then by this definition of a weak axiom, it implies that Y is what? Y is the preference of this set. All right. So, and this contradicts what the question is saying. Question says that X has been revealed. Definitely, there's a contradiction here. So that means Y cannot be the what? Y cannot be the set or the element of or the preference of that set. All right. So when we have this, it's a contradiction. Then that shows that what this stress structure satisfy weak axiom because it does not is not a preference of this subset. All right. So thus we can say that C or this choice is a subset that contain either X or the set of Z or this combination of X and Z, since Y cannot be a choice or a preference of this choice set. So since we've eliminated Y out of it, definitely this subset This choice set will always be a member of either X or the set that contains Z or the set that contains Y, X and Z, not Y. I don't know if we are clear with that. All right. So here we have another example to also explain what Wickersham is saying. This example is saying that suppose or we should show the equivalent. This example is a bit trickish, but let's just follow the procedure and understand it clearly. So this example will enable us to understand Wickersham properly. Suppose that we have those sets. So we should show that the Wickersham is equivalent to these following properties. So here are some properties that was given to us. We know what this means already. B, B prime are elements of what? This coily B. Alright? So, and X and Y are members of X. No, definitely X and Y are also members of the coily B. Then we are also told that if X is a choice in B and Y is a choice of B prime, by weak axiom, we know that xy is contained in CB and xy is contained in CB prime. That is what the weak axiom says. So let us show this property. Are we following?
Yes, you are following. I'm following. Let me not speak for other.
All right, that's good. Mr. Jackson, are you there? All right. So now this property, so let's assume that if x and y are coming from this set B. We are picking two elements from that set. X, we know what X and Y could be any alternative. All right. And we also have another set, B prime. Like I rightly defined, B1, B2, B3, Bn can be as much as possible subset of what? Subset of the preference set. Okay. So there must be a preference set where this B and B. So in this case, B and B are coming from B and B prime are coming from the coily B, which is the family set. So they all contains X and Y and X prime, X and Y. So now, if we have this set, definitely by weak axiom, X is a preference of this choice. Also, Y is a preference of this choice. So what Wickersham says that X will always be the preference. So anytime I have two subsets, if X is a preference and Y is a preference, definitely X is the preference of that set. It's just like, let me explain this again. It's just like you have a set that contains apple and banana. All right. So if apple is your preference and banana is also a good preference of the second set, that means you're having two sets. That means your choice is to pick apple from this choice set one, and your choice is to pick banana in this set two. Since apple was revealed before banana, definitely the choice of this set that contain apple and banana must be what? Apple. That is what this set is saying. Because the first one, the preference was made based on affordability. Okay, so now it means that what this decision maker can afford is X. So whichever set you can combine or whichever subset we can take from this family set, X will always be a preference. So similarly, if Y is taken from the family set. All right. If y is taken from the family set, the y could also be a choice of this family set. So for all sets we have, so I've defined it. This is just a family set. So suppose we, so here is an assumption now. Okay, here is an assumption. So suppose is the way we prove this set, or the way we prove this property, we prove it in two ways. The first way, we assume that the weak assumption, then let's see if those choices will be what, will be met. That means if this order will be met. All right. That is, we assume the choice is satisfied. Then we prove the converse. All right. So we assume that if the converse, if the weak assumption is not satisfied, what will be satisfied will be what? This preference. So that means we assume that if this preference is satisfied, we weak assume would. So these are the two ways, these are the two things we need to show in proving this set. All right. So let's suppose that the weak assumption is satisfied. We assume that x and y are coming from this set, and we also assume that what, x and y are coming from another set which both contains in the family set. All right. So if b and b prime are contained in the family set, so if b and b prime are contained in the family set, so what, then we cannot show that if x is a subset, if x is a preference of this b and y is a preference of this b, then we only need to apply, the weak assumption twice. So we apply for x first, we also apply for y for the second time, then we arrive at something like this, that x contains, so the first one will be for x contain in, x is a choice of, or is a preference of this second set. Similarly, if we do the same thing for y, we're going to have y is a preference of this other set. Hence, we can now assume that, so since x is a preference of this set and y is also a preference of this set, so these two rules hold, which is the first part of the definition of choice structure. If you go back to the definition of choice structure, you found out that the first part is said that if x is revealed, all right, x must be revealed from the set. Definitely y will also be revealed from the set. So once these two are revealed, we can assume that there's definitely x is revealed. So exactly what we have here. So by the time you apply the weak assumption, you apply the choice rule here, so you discover that x is revealed and also y is revealed. So we also look at the converse. All right. So the converse is saying that what, if we have a set, if we let x to be in this set, and we also let y to be in this set, in the set B, and we take x from a set B prime on that set, definitely x is revealed in this choice of sets. Also, x is revealed in the second set, just like we have it here. X is taken from this set, so x has been revealed, or x is the choices of these two sets. All right. So that we can also move further by saying that if I also assume that y is revealed from this other set, definitely the choice of this set is y. All right. So if y has been chosen from this set, What does this implies? It implies that what X will always be chosen because X has been revealed in this first set. X was also revealed here. And in this B prime, X was revealed, Y has been revealed. So by the definition of weak axiom, X should always be revealed. So we can conclude that X is revealed in this set B prime, and in this other set Y was revealed. So once this has been revealed, then the weak axiom is satisfied. So these are just some little proof we need to do to understand how it works. So it's saying what the weak axiom is saying in general is that whenever the first alternative has been revealed, every alternative then should not be revealed. So for the weak axiom to be satisfied. Any question at this point? If there are questions you can ask. Any question? All right. So in the other part of it, remember in this weak axiom, we're only considering weak axiom. We are not looking at the preference relation. All right. So we can attach a preference relation to this weak axiom. So when we include a preference relation, so this weak axiom will definitely become a revealed preference relation. All right. Because in this case, we are only considering what a particular, we are only looking at X from a certain set. We are not looking at the relation between X and Y from this set. All right. So if we attach this binary relation to it, so let's denote it as weak axiom star with star. Okay. To this binary relation with star, just to differentiate it from our usual preference relation. Our preference relation has star and does not contain star, but let's include star with this so that we know that this is what a weak axiom of revealed preference. Okay, so here's the definition. Given the choice structure, we are given a choice structure of this form. All right, given the choice structure of this form, the revealed preference, this star is defined to be what? Is defined to be this. Is defined to be this binary operation. We have x related to what? Y. All right. So this symbol means what? Implies. All right. So there are some words B in B. What is our B? What does this mean? B in B means that there are some subsets B from this family set. Okay. So this B is a set on its own that contains what? X and Y. Then, and the choice of the preference of that set is what? Is X. So that is what it's saying. A reveal preference. So X is our preference from the set. So anytime we are having a choice structure that contains X and Y with this relation that has star in it, so he's saying that what X is the preference of that choice of that set of that relation. So that is what this means. I don't know if you understand the definition clearly. So he said we can read this definition as what? As X is revealed at least as good as Y. So is remember in the preference it is read as X. If there is no star here, it is read as what? X is at least as good as Y. But now X star, we have star here, so it's read as what? X is revealed at least as good as Y. So this is denoting what? A revealed preference. Okay, a preference that has been made open. So uh, when we have a preference of this, so those assumptions or those assumptions of our preference, the usual preference we are used to, those assumptions are not satisfied. What are those assumptions? Uh, Completeness and transitivity, so they don't hold anymore. So, like I have it here that note that a review preference of this need not to satisfy either completeness or what transitivity. All right. So now it means that uh, remember the law of transitivity. So if those assumptions fails, especially transitivity, if x is at least as good as y is at least as good as z, definitely z x is at least as good as z from uh, preference. But in a review preference, the reverse can hold. If x is at least as good as y is at least as good as z, x is at least as good as z is at least as good as x. We can, if it fails to hold, especially for transitivity, then that preference is also is a revealed preference. I don't know if we're clear with this. Any question at this point? All right. So next we look at the relationship between a review preference and a preference and a choice rule. Preference relation and a choice rule. We want to look at their. Hope I'm still loud and clear. So we want to look at their relationship between a preference relation and a choice rule. Certainly, there are relation between these two. So something bounded together, okay? So it's just like a a set that relates our budget set and the choice rule. All right. So in place of this C, if you look at this our budget set, so we are replacing this C dot by the preference relation, this without star. All right, this binary relation without star. So we use it to replace this. So we are trying to, so this choice structure, we just need to change uh, the C dot and replace it with the binary operator. All right, so that makes, so that is how we want to compare, that is how we want to compare these relations together. So with this now is a set. So we have some questions here, okay? So why do we need to compare a preference relation and a choice rule? Why do we need to compare this relation? So we say if a decision maker has a preference relation with a preference ordering with this symbol, okay? So to her decision when faced with choices from this budget set, remember our budget set is our quality B, necessarily generate a choice structure that satisfies the weak axiom. So that is the first question. So not all the time, okay? Not all the time we have uh, our choices sa- being satisfied with a weak axiom. Remember the last two examples I showed here was just to show if it satisfies the weak axiom. In this example, we are just trying to show if the weak axiom satisfy these properties of choice on the choice rule. Remember in this example, we're also looking at how if this choice structure satisfy the weak axiom. So the question now is that is it all the time that the weak axiom is being satisfied? So the answer is what? Uh, there is no definite answer though. So the answer could be yes, the answer could be no, and we could also say maybe if the answer is it. So it depends on the situation we find ourselves. All right. So now if an individual choice behavior for a family set is captured by this choice structure satisfying both values. Is it necessary that is it necessary that a preference relation is that is consistent with this choice? So we try to make one thing in this preference or in choice making is to have a consistent behavior that what we can model to make decision all the time, such that even in our essential or in the essential of that decision maker, that preference will still be correct, will still be consistent wherever situation that decision found or that alternative found itself to be correct all the time. So once a decision or a choice has been made, so these are so these choices now we are trying to make a consistent choices. That is one of the objective of studying this rules of this behavior. So we want to make a consistent behavior. So the question is that is it all the time we can have consistent behavior? So it also depends on the situation we find ourselves. What if you are still following? Are we there? Are we following? Can I get a response? All right. So in trying to make such decisions, so it's trying to make a consistent decisions. So that is why we need to look at the relationship between choice structure and choice rule. Okay. So the preference relation and the choice rule want to make a good decisions between these two. All right. So don't think anyone is following this class. All right. So with this, I think I should just wrap up this class. So if you have questions, you can ask at this junction. I have 2 more minutes to end this class. So the next class will continue from this point. I'm not getting that required response from you guys. Any question? All right. If there is no question, have a wonderful night rest.
Thank you.
Yeah.